In example 3, we're going to go over how to write a integral from a given limit. Okay, so doing the Riemann sum before, we actually took the integral and did the sum. Now I'm going to give you the sum, and we're going to just kind of write it as an integral. So these should be the easy ones on your homework here. So example 3, write the limit as a definite integral on the interval -1 to 5, where ci is any point in the ith subinterval. So we're going to take the limit as the norm goes to 0 of I equals 1 to n of 3ci plus 10 times delta xi. This is a very simple and easy substitution. Do not make this hard. Okay, so the interval a to b, a is -1, b is 5. That's given up top. So you're going to write the integrand. It's on the bottom right hand side of the screen here. It goes from -1 to 5. This is the next part. It's very, very easy. Anywhere we have a ci, we are going to write an x. So we have 3ci plus 10. That translates to 3x plus 10. Anywhere we have a delta x, a change in x, okay, we are going to write dx. So our solution is literally this integral on the bottom right hand side of -1 to 5 of 3x plus 10 dx. Alright, let's do another example like that. We want to write the limit as a definite integral on the interval from 0 to 4, where ci is any point in the ith subinterval. So we're given the limit as the norm goes to 0 of I equals 1 to n of 6ci times the quantity of 4 minus ci quantity squared times delta xi. Once again, replace any ci with an x and any delta xi with a dx. So our solution for our integral here is 0 to 4, because those are on the interval we're looking at. And we end up with 6x times the quantity of 4 minus x squared dx. These should be pretty straightforward and pretty easy for you guys doing the translation. Let's do another one here. We want to write the limit as a definite integral on the interval 0 to 3. ci is any point in the ith subinterval. We're given the limit as the norm goes to 0 of I equals 1 to n of the square root of ci squared plus 4 times delta xi. Once again, replacing any ci with an x, okay, and we are given the interval from 0 to 3. So our integral is going to look like 0 to 3 times the square root of x squared plus 4 dx. So this is our integral. Pretty straightforward. Alright, we're taking the integral of square root of x squared plus 4 dx. That one should be pretty straightforward, pretty easy for you guys. Okay, let's step into the next one. So on your homework, you're going to be given a graph like this one here. Alright, so set up the integral that represents the shaded region. So the shaded region, and we're going to be given an equation. So the equation that's given is f of x equals 4. So it's really just a straight line that goes from -infinity to +infinity at 4. But we're given a specific shaded region for that. The shaded region is what? From 0 to 3. Make sure that we're paying attention to the x-axis here for our limits of integration. So the shaded region starts when x is 0 and ends when x is 3, so that's why the integral goes from 0 to 3. Our function is 4. Okay, so we're just going to write 4 dx. I think that one's pretty straightforward when we do this. Okay, let's look at this one now. We want to set up the integral that represents the shaded region. We're given fx equals 6 minus 3x, okay, and we're given the graph. The graph is going to tell us how to set up the integral. So if we look at the integral is going from what? 0 to 2 on the x-axis. So when we write the integrand, we have to go from 0 to 2, and we write the function 6 minus 3x times dx. So that's all we're really doing right now. It's not asking you to calculate anything, we're just setting up the integral. So next we want to take a look at example 8. We're going to set up the integral that represents the shaded region f of x equals 4 over x squared plus 2. And we're given the graph here. The region is from what? -1 to 1, and it's the shaded in region under the curve here. So the integral is -1 to 1, that's the x, and then the function f of x is 4 over x squared plus 2 times dx. So should be a pretty straightforward translation, taking a look at the graph and writing the integral from it. Okay, let's take a look at another one. We want to sketch the region whose area is given by the integral from 0 to 3 of 4 dx. Now, we're going to do this one on your homework. We're going to be given the integral. You actually have to sketch the shape, and we're going to calculate the area based on that specific shape. So in this case, if we sketch this integral from 0 to 3 of 4 dx, I've done the graph down here. Notice in the x-axis we're going from 0 to 3, and the function is 4, so that means that would be normally a horizontal line at 4. We just make that horizontal line only go from 0 to 3. So we can obviously see that we've created a rectangle here that is 3 wide by 4 high. Now we use the geometric shape, okay, to find that. We know the area of a rectangle is what? Width times height. So we just take 3 times 4 and get 12. So we're able to figure out the area, okay, for this one is just 12. So anytime on your homework it asks you to use a geometric formula to evaluate the integral, you're going to look for rectangles, triangles, trapezoids, all those different things, circles, semicircles, those kind of things. So if you forgot some of the formulas, okay, the inside covers of the book, those 4 pages, that handout I gave you, I believe it's also on the website. It has all the formulas for basic shapes there, but you should know them. So we're going to kind of roll through the basic shapes here pretty quickly. If we look at example 10, we have to actually sketch the region. Okay, we're given the integral from 0 to 6 and of 6 minus x dx. So to do the solution, the first thing is we should probably graph it. Okay, so from 0 to 6, and then we graph the equation. The graph looks like this. Alright, and it's restricted on the x-axis from 0 to 6 and by this equation. We can obviously see that it's what shape? A triangle. We use the area of a triangle, which is 1/2 base times height, to calculate the area here. So 1/2, the base is 6 units wide. The height is also 6 units wide. Alright, so it should be 1/2 times 6, which yields an area of 18. Okay, the next one's going to get a little more complicated. I'm going to start that one in the next video. But that should be the easiest ones for you guys as far as basic shapes. Looking for circles, semicircles, trapezoids, rectangles, and squares. So any part on your homework that asks you to use a geometric formula, draw the graph from the integral. Okay, so sketch a graph for yourself, see what shape it ends up making, then use that shape to find the area just like you would have back in geometry.